Okay, hello. We are here today at GeeCON to hear about some new stuff about database. And I can let you know in advance that this is for everyday developer. So I try to bring you a new topic for it. You need to understand databases and especially SQL as a language. So our agenda today includes a brief introduction about some kind of workloads, data models, about e-commerce, data that we need to store. We will see what is BigQuery. And we are going to go into BigQuery ML, a section of BigQuery that let us to execute machine learning models inside SQL with SQL syntax as well. With that, we can predict, recommend, annotate, forecast, and a lot of inference. Nowadays, this is this nice word, inference, to run machine learning jobs and so on. My name is Marton. I'm Hungarian from Romania. And my credentials are that I answer a lot of questions on Stack Overflow. So I recommend you should do the same stuff. I built out a reputation profile there. Yeah, you're smiling. Yeah, that's 200,000. You should build up yourself as well. I'm a GDE on Cloud Technology 2016 and a champion innovator on the Google program itself. It's my second time here. Last year, I was here with Vertex AI, the AutoML solution and pipelines. And when discussing with the audience, it was actually a demand to come with BigQuery because this is my specialty, to say so. So I'm back here, and hopefully you will enjoy the topics as well. I write articles, and the slides will be available on SlideShare, Twitter as well. I have 2 stage names, so you can contact me anytime, and so on. So whenever we are dealing with some data that we need to collect, we may have a shop that could have features, attributes. The users could have engagement, which means that, let's say, feedback, favorite stuff, like stuff, visit favorite pages, and so on. On top of that, the users turn into customers, so they make orders. And the orders, the order product itself, lets you to actually run analytics. And in order to have the analytics, you need to actually store and grab all the data of it. So I can go longer and longer. Nowadays, data is something that covers everything. And the first step is that we need to highlight the type of data that is hard to collect and hard to store. Essentially, I call this raw data because you may store, or let's say at some point in a project life, you may store it as an average, but we want to store it as a raw data. We want to store every hit of it, every variable that's available for us. And that leads often to a question like where to store all this raw data, and especially raw data. So for that, there are multiple solutions on the internet, but my topic today is focused on BigQuery, which is part of Google Cloud Platform. Even if your project or something is not part of the BigQuery of Google Cloud, you can still use BigQuery and from Google Cloud this section of the product itself. Essentially, it's analytics as a service, a data warehouse, so you can store a lot of stuff. It's a familiar DB structure. It has all the nice stuff that recently has been introduced with nested JSON structure and so on, so it's favorable to work for you. It has a very decent pricing. So the storage is only 20 for a terabyte a month. The queries, it's going to cost 7. They just raised from 5 to 7. From July, they will raise this cost. It looks very appealing. I have projects where our bill is only 300, and I don't need to open any service, any server, any infrastructure. We just run the managed service itself. It's based on SQL and JavaScript, scales into petabytes. Nowadays, Google replaces this kind of stuff with petabytes to exabytes. BigQuery grow very, very large. And it integrates with all the ecosystem of Google Cloud. And especially, I highlighted 3. Cloud SQL is the RDS of Google Cloud. So you can join, for example, with MySQL or Postgres queries, literally join. Sheets is the Google Sheet, which is the consumer product, where the Excel type of thing, marketers could use that, and you can join with a sheet from BigQuery, so that's helpful. And Data Studio is the visualization part of all this service for it. And today we are going to learn about BigQuery machine learning that will let us help to run SQL queries. I won't go deep into where to use BigQuery. You eventually can visit the slides and see that data warehousing, real-time analytics, business intelligence, machine learning, and in a nutshell, for everything complementary to an operational database. That means that you run your website, project, API, whatever, on your chosen database, and extensionally, because data is cheap, you store the same stuff or in a raw format also in BigQuery or similar products as well. The name is appealing, like BigQuery, Google, so it must have some superpowers. BigQuery has superpowers. Essentially, this is a screenshot of a query that is trying to process 1 petabyte of a table. And BigQuery is able to handle this. So it took 2 and 8 seconds. And in the end, it pruned a lot of results out of the billion. Out of the billion results, it's only 400 megabytes processed. Essentially, I didn't do a table scan. So table scan, even in BigQuery, is slow. But in queries where you target a specific, let's say, context, it's extremely fast, and you can store with petabyte. You may wonder that this query might cost you $5,000 or $7,000 because a petabyte is $7,000. It could be. But you never need to do a full table scan of a petabyte. So that's out of the question itself. It will be a fraction of it. Also, BigQuery introduced clustering, and introduced clustering in a way that it's out of the box. You essentially, you see the same stuff, but here there is a V2 and there is a V3. So the same table, Wikipedia, which is available, by the way, because Google puts all the Wikipedia, Stack Overflow, Reddit, raw data available in SQL format, so you can query Reddit, query Wikipedia as you hear. It's accessible to you. The one doesn't use any partitioning, so it takes a lot of time and a lot of processing. The second uses partitioning on the date and clustering on the wiki and the title, and it will reduce drastically the data that you are going to scan. Good. I also want to highlight some specialty superpower. You can load file. You can load a file. It's up to 5 terabytes, so you can create a really large file and to upload to BigQuery. It will ingest it like that. And also has a streaming rows approach where you can ingest 3 gigabytes per second. So you may, for example, run a company with a lot of IoT metrics. The data is coming like, you can store that in BigQuery because it lets you to store 3 gigabytes per second. There is an API about this where there are these metrics, that exactly once matrix. You need to use stream offset. That's for advanced people, because often when we are dealing with data that's had a speed, often I get a question that it doesn't work. It has gRPC, so it's optimized for the low traffic and handshakes, and are guaranteed ordering with asynchronous request as well. OK, there are other ways to work with BigQuery, like function and export from Firebase. You may use Firebase for your services, or export from audit logs or log syncs. So anything which is a log, which is a data in Google Cloud, it's available also on BigQuery. And now it gets dark. I'm not seeing you anymore. Thank you for the person who dimmed the lights. Join with Cloud SQL. This is also a superpower. Essentially, if I write a BigQuery query, I can literally join with an external system, which could be your SQL, your MySQL, your Postgres. Normally, it won't have the speed of BigQuery because the slowest component is driving the speed. So your MySQL Postgres will write this. Essentially, what is the use case of it? When you need a table from the, let's say, operational database, you can run this type of queries to bring it over in BigQuery. And once it's over, you can run in BigQuery any data wrangle operation you want and so on. Capturing the data, there is this big chart, somehow similar to the previous talk. Essentially, there are different services that produce data. We use FluentD to route the data to different subsystems. The same data is routed to multiple systems. It can go to other application servers, which write to the standard SQL database. It can go to this route to the cloud storage for archiving. We archive every event because we may need to replay them once in a while in order to process it again with a new functionality. And also the same data is written to BigQuery. And then the analyst or the developer itself can use and can create dashboards out of it. Benefits: store everything with no capacity problems. It's a managed service, so you just need to add your billing card. You don't need to provision servers. You don't need to install anything. It's full managed service and so on. It's serverless, and we have changed and shifted the way that how we use data. We store everything, even if we don't need it, because in 6 months' time or in 1 year time, we may need that information, and we have it available. So the question is that whenever I get a context, can you run this query? Okay, I have the data. I need 2 days to organize it in a way that's for the context, but I have it. I don't need to implement new code from now on. Good. And now to BigQuery ML. BigQuery ML is a revolutionary model in the SQL language. Essentially, it lets you to run not a create table syntax, a create model syntax in the SQL. And it introduces machine learning capabilities to everyone, which could be a general programmer or everyday programmer, as I call it. And it grew out so big that it has a lot of models itself. Nowadays, initially, it was only the built-in models. But nowadays, there is this built-in managed models, which are out-of-the-box solution for common ML inference. I will talk about what kind of models there is available. We have it available here. The good thing that they allow now to import outside models of BigQuery, which means that if you found a TensorFlow, PyTorch, everything from the ONNX family, a model readily published on the internet, you can import and run in BigQuery. What that means exactly, it means that you have a tabular table, a data on your tables, and you can run the inference inside the BigQuery. You don't need to take it out. You don't need to span out any application and so on. Also, Vertex AI is a new, let's say, product section in the Google Cloud. They will launch generative AI as well under this Vertex AI thing, and all these kind of new things. Probably it will come in August, because Google has in August a flagship conference, Cloud Next. So there will be full of great announcements there. And also, it has access to Cloud AI models under, let's say, Vision API, Translate, or on NLP and other APIs, because Google is full with Maps API, Places API, and Translate, and all this kind of stuff for it. A brief about the model selection guide. So essentially, there are ways to predict values to stock prices, sales figures. We can use different models here. These are model types. Also, we can predict between categories, not just values, where, for example, to tag or to label something that is spam email or a visitor type and so on. Normally, we have the data in BigQuery about these metrics, and nowadays we can use the SQL language to have this. There are different models available, and each model has their own hyperparameters that you can adjust and so on. There are tutorials for every of these on the market, and you can try it out. You don't need data scientist experience. These are plain syntaxes. Also, you can, for example, run product recommendation, matrix factorization. It will be today later explained. And find anomalies, for example, k-means. It's a great way to quickly identify oddities in your data as well. And other ways to group into clusters or do forecasting. I use forecasting in manufacturing, like when is due to change the component on the elevator in this multi-kino, like every 3 years, something like that, based on the history of failures. So this kind of forecasting I'm using for it. This model selection guide is available normally on the Google page, and it has a lot of hierarchies and leaves. So you should check it out. I won't spend too much time to explain this. And let's get practical, because so far I'm saying bullet point items. Yeah, you can come in, literally. You can come in, don't stay there. There are places here, so you can sit it down to see better the code and everything. If I need to create a model that predicts whether a website visitor will make a transaction, let's analyze this kind of context. This kind of context coming from data similar to Google Analytics. So essentially, we need to select the features, the input to the model itself. And you see here a prefix and a create model statement for it. So what's happening here, in a nutshell, we are not creating a table, we are creating a model. The model type is logistic regression, and this is a chosen type out of that 20 which I just showcased for you. And there are different ways. Select features, input, in SQL Word is a select to say so. So down from here, like operating system is mobile country page views, these are the inputs to my model. This is just basic, just to showcase you what I know about the user and what that. But normally this is not 4 columns, it's 200. And a lot of 200 columns are initially null, null, null. And as the user advances on the website, you update and you measure each feature that you implemented and so on. So that's how the process is going to build out for you. The label is the one that is the training phase, and you give the label here that eventually did they transaction or not. So this is the one that is used on the training as well, and normally this is a table prefix because I trained on 3 months data or 1 year data or the last week data and so on. Normally this is not running as fast. It's not like create an empty table. It has a time. In this time, it runs for 7 minutes. It depends on the input size and so on for it. Good. Next, normally you can evaluate the model. You have functions for that. So eventually, there is a syntax which is hidden in the from statement. You select from ML evaluate. You add the name of the model. And then you select the same input, but now with a different data set, because you should not validate with the training data. You need to validate with an unseen data for the model itself. You get some numbers. I'm not saying that this is right, because I just created the basic model to show you on the slides as well. This can be improved. And normally with 4 columns, you don't get high precision and a lot of good score for it. But just to reference you how you need to run the operations. And then there is the predict. The predict uses the model and no longer has the label column. It only has the inputs, which let's say that the output here will be the label, because that's the predict outcome of it. And the label is in an array syntax, so I also get the probabilistics of it. And I can actually see that this is 68% suggested for my results as well. Good. This is just the basic syntax. You need to spend some time on it to see on your data in order to see how it's performing and so on, and eventually discuss with the team how to improve this operation as well. Now that we know basic syntax, and as you see, it's much more for everyday developer, let's see some other model types and examples how we can use and benefit from out of it. So with k-means clustering, we can, for example, analyze customer segmentation or data quality itself. We have the create model where we add k-means as well, but here outside of predict, we had other functions which are helping us in this process. Like, for example, we can get how many centroids are. We can even get the distance from the centroid in order to plot the points of it. We can evaluate training info and feature info. All these are available functions in order to analyze the model itself. Essentially, we can encode everything in a column-based solution, like in a yes-no encode mode. Think booking.com here and a property. You enlist a property. It may have 60 features. And you encode that with yes, no. And you can apply clustering on the encoded data. With clustering and obtaining the centroids, there are 3 centroids in this picture depicted, and the distance for it. You can detect the farthest from the centroid, and you can name that, for example, outliers. So, for example, in a practical way, on booking.com, the outlier could be that someone listed the property and forget to mark that there is television. So they forgot to add that they didn't add a television or bathroom, for example. It could be a data error or user error, input error, but your system could detect this. Like, hey, probably you should have a, I don't know, bathroom, but you didn't mark it. And you can send out an email campaign for that to remind them that, hey, you did this, do this error. This is just a basic example to showcase you the capabilities, but also business-wise, you can group closest elements. Also, you can group the finest elements. And you can also use in a customer segmentation that I need 10 people from the centroid of a feature, and I will use that in a campaign and so on. Matrix factorization. Well, this is one of my favorites. It's actually a product recommendation model. So it will target the product to the customer. And it's available, let's say, in an Amazon shop interface and those kind of interface, but straight out from the database itself. It's very easy to understand. It does magic. What is happening is that this is, let's say, the available data. I have here the users. I have here the products. And I see that how many, I give a score of people touching a product. And I see that coffee is not used, for example, by many of them. And one of the marketing and product people come to me, okay, we want to promote coffee to the users. I have budget only for 5,000 customers. Our database could have millions of users. I have only 5,000, budget for 5,000, and give me the top 5,000 likely users that will buy coffee and so on. So essentially, the matrix factorization problem, it will assign values for previously unknown values, or zeros in our case. So we have a bunch of zeros here because coffee is not promoted, the users are not using it, and which would be the most likely user to buy coffee. So these zeros will be filled by the algorithm itself. So here in the results pane, you see that these are filled. And essentially, this is the matrix factorization of it. So what I do is that I order these results, and for example, Peter and Jennifer will be one of the top users that likely to convert to buy coffee. This is an interesting problem, and you only need 3 columns from your database, like the user, the item, and then the score or a rating of it. It's very simple. So you have a create model, matrix factorization as a type, and the 3 columns which I mentioned. You need to compile that from your dataset. And when you recommend, you will get this. Now, I had questions, and people approached me on Twitter that when they run this, they incurred a lot of costs. Well, because they actually run it for each user item pair out of the database, because it doesn't have any where statement, so it built out everything. out of it. So you need to add there a where statement, like I want it only for John, or I want only for Poland users or Krakow users. You need to segment that down, not for the entire database. ARIMA Plus, just briefly, it's a forecasting model. Essentially, it's a chart. It's not Bitcoin, it's not stock, it's just a chart. It could be maintenance or something like that, and it can continue. So this is existing data until here, and this is forecasted data and so on. Okay, so far you have seen that I'm column-based. So I'm using data from my database, but BigQuery introduced an object table notation. And object tables are a way to files. So I'm able to create an external table. Actually, I have here information where I can add URIs path to folders to use from the cloud storage or from S3 if you are on Amazon to say so. And out of this, it will create for me a table of the files itself. It's damn helpful because I can build out a solution that the marketing people just adds data into a folder, like a CSV file, but it could be a PDF file, it could be an image file, or it could be something like a thumbnail that somebody creates and uploads a profile picture, and I have it in my table. I don't need to create an API to parse the files. I don't need to be in the, let's say, in the product website or mobile application. I could be in the database and do stuff on these files as well. These are called object tables. There is a connection which is set up in the interface. So based on this connection, it has the proper authorization what folder to access it, because normally you should not access, you should not have rights to access everything. So based on this connection, you set the permissions, and there are different options to actually see it. What I like about it is that here we are reading this folder, which I want these files out of it. But if I have a different folder, I can use a different folder structure and still compiles in the same table. So I don't need to use union and other ways to merge data between tables as well. This is how it looks in practice, where I select the table, I see the full path, and timestamp, MIME type, size, updated, and every other operation. So I can magically access via SQL files stored in cloud storage. I can join with other tables, business tables. I can run inference normally because BigQuery ML is there. I can run inference on files. And I can analyze objects tables by using remote functions. Remote functions are an amazing stuff. I will demo today for you. And normally, you can query data in Google Drive. I often get the question, why only cloud storage? Why only S3? There is Google Drive. Well, it's possible also to access Google Drive. Actually, it's so easy that you can join with a sheet, and programmatically, you don't need to do anything. Anyone updates a sheet, like a marketing person, the data is magically updated, and the query itself uses as well. As I mentioned, between the model types and ways to work with BigQuery, you can import TensorFlow models. So essentially, you have here model type TensorFlow model path. You need to upload it to a cloud storage, the model itself. Right now, the model should be between, under 250 megabytes, so it doesn't accept large models, but let's say that 250 it covers a lot of things. And this is how you work with it: create model, the folder where you have placed downloaded the model, for example, ResNet 50, and then you can do a predict. And there are other functions, like if you need to decode the image, because normally you have access to the binary of an image, of a file, you need to use a decode image function in order to use it. And input one here is actually the model description tells you how you need to name and what are the columns that you need to add as an input for them. And it will respond in this time with something like activation 49, if you know the model itself. Good. Remote functions. Well, This is not ML, but it's a handy tool, and I use it very, very frequently. Whoa. Yeah. I will show you better how it works, because it's straightforward for that. Let me go here. So, for example, everything is fine because we are in big screen. I don't need to zoom. We have here a create function statement, and we have here a cloud function, a lambda. A HTTP lambda, as you are used to deploy functions and so on. I can consume this inside the database itself. So essentially, I have a function which is, let's say, address detection from here, and I can input company name, and my response in this way, I'm using the Google Places API, which is a common API. And this Places API, for example, Google Krakow, it returns this JSON. I have here the address, multi-key. I have here the address itself. You may not realize it that I'm in database. So if you have a column that's only multi-key Krakow, and someone asks you, plot it on a map, first you need to get an address. So you can use Places API in order to get an address for it. It gives you one score, but this score is not a match score. This is a similarity with the name that he used to find it. So it returns you the name that it finds you. And you can decide it if it found the same stuff. Normally, there are real-life conflicts here, so it won't be 100% good for all the solution, because I had to add here like Krakow. Otherwise, Google, it would give me Bucharest, because I'm in Romania, it biased to Bucharest. But if I'm able to change that, it will give me Mountain View or something like that. You have the opportunity. Places API is a function which, I need to add here, which is a function I deployed. I used Python here, for example, and pretty much this is, and it encapsulates the Places API in order to read out information. And the bias is here, so I had to add a bias, like where, because if I would place there Mumbai, it will give me results from that area as well. But normally, this is Maps API encapsulated in a cloud function, consumed in a database environment. Fine? Good. Now that I have an address, I can use geocode, which could be another function. This is the URL that the function is published by the system. And if I take out the address, I get coordinates. So latitude, longitude, out of it. I'm still in the database. And I can plot it normally, but I can tell you something like, for example, I built out something like this. This is Romania. In a short, the government launched the funds that Horeca, hotel, restaurant, catering companies could apply for photovoltaics on the roofs. But they also inquired, like, they need to put electric car charging stations. And as a fan of electric cars, I wanted to plot the data on a map to see where will be these charging stations. I obtained from the government a list of company names. They didn't give me address. It was a 60-page long PDF for company names. From company names, I used the Places API to actually get an address. From the address, I used the geocode to get a latitude, longitude, and this is the work of it. It was like 4 hours, and I didn't know nothing about this service until now. I just copy-pasted stuff out of it. And normally, this is Data Studio, so you can have the query itself, and it's organized by counties and everything as that. So Romania will have this many stations in a 6-month period compared to what it exists in Romania. We have a phenomenon. It's called Dacia Spring. It's full. We are full with that. It's a cheap electric car. Sorry. Good. We call it a phenomenon. because we never expected that Romania will have so many electric cars. That Dacia Spring changed this. Essentially, in the slides as well, normally you have charts as well in the models, so you can check your models as well to how it's performing, and there are cold starts. So database and the places API is still the slowest component, and there are cold starts. Usually the measured cold starts of a function and so on, it could be something like 600 milliseconds. That's how we measure it. It depends. Python a bit slower than, for example, Node.js. But if you need fast, you need to develop in Golang, and that will be like a binary, like 50 milliseconds boot time for that. Also, authorization, I need to expand a bit on authorization because I get frequent questions. The paths of the storage file are not just paths like URIs. It's not an authorized URL to get the binary. And there are authorization flows like, do you have permission to read the file? In order to maintain that, there is a concept of external object transform, like a function. And there you have a way to obtain a signed URL. And I like this process, even if it adds clutter to the data. I like it because this way it's audited. So it means that the managers every time ask me who accessed that file or what system accessed that file, even if it was a database or a BigQuery, in the audit logs, I have this access if it's an authorized URL. And normally, I can shut down the permissions and so on. Actually, it's always closed. You need to open up when you deal with these queries as well. On top of that, there is max batching rows. Normally, for every row, it won't do a separate request. So you are able to write and do your Google Cloud function in a way that it accepts a batch of rows. And that way is easy to decide because also the places, maps API, and whatever API, it could be your API. So I just demoed the one that I'm from Google, but it could be your API developed there. There you can set the rate, and there you can tell to BigQuery like how many batching rows you want to expand and so on. 100 is a good number to start with. We have seen saturation around 5,000, so it depends on the cluster and the type of data you add. And normally there is a cold start. So usually these queries are not in a live system, so it could be up to 5-8 seconds until everything is processed, and depends on how fast the cloud function will auto-scale up and so on. But nowadays, serverless is not invented this year, so it was invented 10 years ago. So auto-scaling on serverless is damn fast. You just need 2 seconds, and you are at thousands, 100,000s of instances and so on. Good. Conclusions. What I wanted to tell you about BigQuery machine learning is that it democratized ML with tools and spreadsheets and all the stuff. Teams trained with SQL only. So no Python, Java needed itself. It's good for everyday developer. No need to export data from the warehouse. You are in the database itself. Models serve a purpose and are adaptable. It means that as it's easy to create tables, that easy is to create models. And you create different models, and it's very easy to actually try out different combinations of columns and hyperparameters and so on. Enhances innovation and expedites model development. This means that whenever you go back, let's say Monday, into your project, you could decide that, hey, we have a context where we could leverage one of these models. You build out the import into BigQuery of the data, and then you are next day working on a machine learning problem without being a data scientist and so on. Normally, it has a limitation. So it's when you need to build out something niche machine learning model, you need the data scientist stuff. But it opens a lot of possibilities here for it. Good. The possibilities, it could be in marketing, retail, industrial, media as well, gaming. And often I see people using customer value, funnel conversion, and there are maintenance needs, which I have a project of it. Like it tests the mechanics that in 6 months, this is the demand for the maintenance needs. You should order the tools or replacement, the parts of it. These kind of things. It enables product recommendation. As I mentioned, this is a favorite of me because it's very easy to build out product recommendation out of the database itself. I don't need to do graph. I don't need to do any other magic problem. Normally, if you want to make it better than the out-of-the-box model, you can go. I'm not saying you cannot go. Initially, in the very first beginning of the project, to go fast to market, it's a great tool to actually do it immediately. And I have a lot of much more deeper content about this. So about my articles, why I had to press this, sorry. So on Medium, there will be automation with cloud workflows. There will be articles how to reduce the BigQuery bills. There will be how to automate Vertex AI training task. I have an extension, GCP project switcher for VS Code. I can show you that. I still have that time. So this is my VS Code. And here in the section, where it is there, in the status bar, it shows me the project on which is highlighted on Google Cloud Platform. And I created an extension. It's a GCP project switcher. And it lets me to quickly see and deploy stuff there and well, because I switch projects and so on very often for it. Good. And as I mentioned, I have some previous presentations. Some are also from GeeCON last year about Vertex AI, which is also an everyday platform, but it's much more for data engineers. This was for everyday developers and database practitioners, but that is for data engineers, and Vertex AI is a nice tool to actually grow big. Thank you for having me here. If you have questions, you can post to GeeCON and select room 1. Also, I observe that organizers are collecting feedback on the post section, so you can provide feedback because I want to shape this talk in a direction, and I need feedback to see if I should make it simpler, separated, and so on. And in this orange T-shirt, I will be here probably all day, and we can talk, discuss in the corridor as well. So I was super happy to be back here in Krakow. Let's see if we have any questions, right? Oh, 5. Let's see, probably whole for me as well. I don't have that nice interface, but we can still manage it here, right? First question, do you also handle continuous transactions on BigQuery? BigQuery is a complementary database. So if you are let's say in a regulated or financial business, you have an operational database where you handle per regulation the transactions. You synchronize to BigQuery this information, and you can normally do updates. But what we prefer and how do we store is append-only stuff. This way, even if something is updated, with append-only technology, I'm able to see in BigQuery 20, 30, 50 lines of code and how it changed. What's the benefit of it? I can pick the last one, which is the most recent update of the data, but I can run also machine learning, like how the process was, what has been updated, because I have all the intermediate state of the data, how we reached to the last point as well. Okay, who's managing this? Because I don't know who marks it. Thank you. I didn't know you have this content. Okay, next one. When generating a linear regression model, does BigQuery support nominal values, or do you have to break down into numerical values yourself? Well, That's a good question. Probably I don't have the answer for it. I've seen the process that we need to encode, in a way, details in a many way, and probably you need to do it, but I'm not having the answer for that question. Maybe we can Google it up together to see and learn something from this question as well. Good, it disappeared. Can you limit the possibility to have full scan either when you train models or just browse the data? When you create a partitioned or a clustered table, at the creation, there is a specific syntax that you can require partitioning filtering. It's a param. And when that is set, it means that whoever writes a query cannot do a select everything query. They need to add a where statement. If their choice, if the where statement still scans the full table, but they are forced to write a where statement. On top of that, because in BigQuery we are dealing with petabytes of data, the concept here that you may limit some data is to use materialized views. That means that material view is a live copy of the table, and you can use a where statement to set that materialized view set, like only to have access to last 24 hours data or to have access to last year data. And that shows up as a table and in the query itself. On top of that, this is a fragment question. We never give let's say, to developers access to raw data. So I have let's say, a data set where I store only the raw data, and I create a second data set where I create views, and the views are accessed by developers. And this way, I hide all the clutter and all the lots of data from the users. They still have access to the data, but in a way that I control them, in order to not mistakes of running Petabyte Query and so on. I would like to discuss this topic, so find me on the corridor. Next one. How predict can be evolved in low latency manner? What is the ETA in this case? There is no low latency in data lake, in data warehouses. We have, let's say, cold start or whatever. So everything what you see here on this scale, it could be from 3-4 seconds up. It's not like that. So it's not an operational database. You can still do it. We do in live applications, but in a way that the flow of the users is doing something else until we wait for the query itself. So you can mimic that option. And normally, if you accept 2-3 seconds here, and then it's fine. Usually, even if you don't do BigQuery machine learning, even if you do like Python machine learning, there could be 8-10 seconds to do an inference. So machine learning is a different concept here. The benefit here in BigQuery is that you can run batched, like for 100 customers, for 1,000 customers, and so on. You later cache that information near to your application, like in a Redis or a Memcache, and you serve the data from there. But it will be available now not in a low latency way, in a post-processed way. Technologies today presented are mostly serverless. How we manage security in case of sensitive data? Do they support some pseudo-anonymization? Yeah, it's a long story. It lets you to use your customer encryption key. So banks and so on, they upload their customer key file, and everything is encrypted for that. On top of that, I, as an admin of the database, I can put masks. There is a data mask concept. So if I give access to the users table to you, let's say in a social security column or in an email or location, you see only hashes. I mean, hashes of it. You don't have access to it. If you need, you can still use the query, it works as it is, but if you print it, you don't see it. But you can do aggregation on it, even if magically is there. And lots of this stuff. So this is not a requirement in 2023. It's a product that was developed over the year of development, and develop for it. I need to finish in 10 seconds. Can you limit? Now, how would I go about loading a whole database from MySQL server into BigQuery? MySQL has a syntax of export to file. You can use that if you are in the command line. I export to file like CSV. This is my favorite way to do that. We create a large file. Export is, let's say, it doesn't press the database, so it will run slow, and it won't pressurize the queries, and it won't lock the tables of MySQL, but it will create a large file. It could be up to 5 terabytes, and you upload to BigQuery. The import, it will be like that. So mostly to upload the bandwidth, it will take minutes, and import will be like that. And we do this, for example, every hour. So the common way to migrate tables is to actually export from MySQL and upload to BigQuery as well. I answered everyone, hopefully, yeah? OK, my time is up, but I'm happy to answer any questions. I will grab all my tools to free up the stage for the next speaker. And tweet me if you have photos, mark me on LinkedIn, because I love this kind of stuff. So let's build out network and so on. And see you next time, whenever we'll be that. Thank you for having me here.